Good morning all of you. In the last video, we have studied about Newton's second law of motion. Now in this video, we will see some of the applications of Newton's second law of motion. So some of our day-to-day observations can be explained in terms of Newton's second law of motion. Let us see the first application, which is a cricketer lowers his hand while catching the ball. Yes, this we all have seen while watching a cricket match, that if a cricketer has to catch the ball, he lowers his hand. Why did he do so? It is because to catch a fast cricket ball, a player pulls his hand backwards to prevent injury to his hands. By doing so, the player increases the time. So by lowering his hand, the player increases the time. Thus, the acceleration of the ball is decreased and therefore the impact of catching the fast ball is reduced. That is, the player has to apply a smaller force against the ball in order to stop it. From this expression, from this second law of motion, you can see that if the time is increased, then force applied will be decreased, because force and time are inversely proportional to each other. So by lowering his hand, the player increases the time, therefore the force decreases. The ball in turn thus exerts a smaller force on his hands and the hands are not injured. If the ball were stopped suddenly, the high speed of the ball would be reduced to zero in a very short interval of time, and therefore a large force would have to be applied for holding the catch and the hands of the player would get hurt. So to prevent the injury to his hands, a cricketer lowers his hand while catching the ball. By doing so, he increases the time, therefore the force on his hand decreases and he does not get injured. Now let us see the next example, that is use of seat belts in car. All the cars these days are provided with seat belts for the passengers, which are rightly called safety belts. The purpose of seat belts is to prevent injuries to the passengers in case of an accident or in case of sudden applications of brake. And in both the cases, the large momentum of the car reduces to zero in a very short interval of time, resulting in the development of large force causing injuries. So, this stretchable safety belt worn by the passengers of the car exert a force on their body and make the forward motion slower. The time taken by the passengers to fall forward increases, and when the time increases, therefore the rate of change of momentum of the passengers is reduced. Thus, stopping force acting on the passengers is reduced. By increasing the time, the force on the passengers is reduced. They may not get injuries at all, or they may get away with minor injuries. So the same concept is being applied over here. Safety belt increases the time, and by increasing the time, the force decreases, and when the force decreases, the person gets less injuries or may get away with minor injuries. So seat belt in a car prevents the driver from serious injuries in case of sudden brakes or accidents. If there will be no seat belts, this might happen with us. So the other applications, or some of the other applications of Newton's second law, is a karate player breaks the pile of tiles or bricks with the single blow. We all have seen that a karate player very swiftly breaks the pile of bricks or tiles. So when a karate player strikes the pile of tiles with his hands, he does so as fast as possible. In other words, the time taken to strike the pile of tiles is very small. And why he do so as fast as possible? Because if we take less time, the force applied on the tiles will be more. So if we do this in a very small interval of time, Therefore, a very large force is exerted on the piles of tiles, and this force is enough to break the piles of tile. Also, we have seen that a boxer moves his head backward when his opponents blow a punch. The same reason is here also. So by moving his head backward, he increases the time, and by increasing the time, the force exerted on his face will be less. So the force exerted by the another player will be less on his face. So when he moves his head backward, then the change in momentum of the punch of the opponent player takes place in large interval of time. That is, it increases the time, and hence the impact of the punch, that is force on the face of the boxer, is very less. So these were some of the applications of Newton's second law of motion. Now let us summarize the Newton's second law of motion. So the statement for Newton's second law of motion is: rate of change of momentum is directly proportional to the applied external unbalanced force, which can be written like this: force is directly proportional to rate of change of momentum, which can be written as m into v minus u upon t, where mv minus u represents the change in momentum and t represents the time. And to understand Newton's second law of motion, we have understood the term momentum first, which is the product of mass and velocity, and momentum is denoted by the letter P, and the SI unit of momentum is kg meter per second, and it is a vector quantity. So this was all about Newton's second law of motion. In tomorrow's video, we will see Newton's third law of motion. So I hope you have understood the Newton's second law of motion.